Cool. So let's talk about getting visibility into the systems that we all run and that we all help build. And the way that we should do that, or the important thing to remember, is that perspective matters. I particularly love this, which let's see if it'll play. Is that not playing now? Why are you not playing? This is cool if it plays. There we go. I don't know if you've all seen these. These are called the ambiguous cylinders. It's a fantastically cool 3D printed thing. Depending on how you look at it, they can look like squares or circles or overlapped. And so when we think about visibility into the systems that we're building and maintaining, it's important to understand that perspective matters. The histories that we each have, the experiences that we have, shape how we perceive things. This leads to biases, right? Because our past informs how we understand what's going on. But the way to get around these biases really is to get new perspectives. So quickly about myself, what are my perspectives? Well, as mentioned, I was a former chef. I do love whiskey. I'm also a Pokemon, I'm still addicted to Pokemon Go, so if you see me wandering around later, I'm not lost. I'm just trying to catch something. I am on Twitter, and there's my email, so if you think of questions afterward, feel free to hit me up. I do work for Datadog. We're a SaaS-based monitoring platform. Give you an idea of the scale of what we handle. We do trillions of points of data every day, and we are hiring. So if you're looking for a new career, doing really challenging work, helping other people monitor their systems, go ahead and hit that link or talk to me later. And I do want to put the caveat out here. I am going to talk about monitoring. None of this particularly has to do with Datadog. There are plenty of tools out there. There are great vendors out here in the hall that are not Datadog. Datadog is out there as well. And there's tons of really great open source projects out there that can help you do all of what I'm going to talk about today. So my job as an evangelist really is to help inform you guys, help you out, and understand your situations regardless of the tool. So if we think about visibility, how are we getting visibility? Well, traditionally, we think of the software lifecycle like this, right? You have development, you have people building the software, and they pass that over to some sort of QA. That gets passed on to operations, who then deploys it somewhere, and maybe you've got some monitoring at the end. And when we talk about DevOps, we talk about breaking that down and mixing this up. And so you often get diagrams like this, and this is the Venn diagram for DevOps that's on Wikipedia. And it shows that DevOps is this overlap of devs and operations and QA, and it's in the middle. And I think this is a horrible abuse of Venn diagrams. And people always do this with Venn diagrams. And this makes you think that the overlap, that DevOps is this overlap, that you can have a DevOps engineer. You have one person that's doing development, operations, and QA. And we generally in the DevOps community understand that this is wrong, right? That DevOps isn't about one person doing everything. I love this definition of DevOps from Damon Edwards and John Willis, who coined CAMS at the very first DevOps days in North America. And CAMS stands for culture, the culture of collaboration and learning. Automation, so accelerating what we're doing with automation and trying to reduce errors with that. Metrics, to measure how well we're doing and understand where we can improve. And then sharing, so that we can all share information together, spread that information, keep teams working together. So with CAMS, there are no Venn diagrams, right? The circle here is DevOps is everything. DevOps encompasses developers, operations, and QA, but really what it is trying to get perspectives, new perspectives on our systems, right? So in order to get that 100% visibility that we need for monitoring, we have to bring in these multiple perspectives. So what that means is, when we think of our applications, we need to get away from this, the traditional view of the stack, the idea that we have siloed front ends and back ends and infrastructure, the idea that we're running a 3-tier or 4-tier, or however many tiers you want to add. We don't want those tiers. So when we talk about breaking down silos in DevOps, what we're really talking about is systems thinking. We don't have a stack. We have one thing. We're all working on the business application that our companies are running. What we're really thinking of, rather, is getting these perspectives. If we think of systems thinking as our systems are a whole, then we can start to look at each of these as a new facet, a new way to look at that one singular system. So if we take a look at our systems and we break things down as a facet, what are we looking at? Well, if we take a look at the infrastructure visibility side, what are we looking at? We're looking at the data of metrics and logs. And I think you all are very aware of these tools. So metrics, you often have infrastructure monitoring, things like Nagios or Prometheus or Datadog. And then you have log management. So I think almost everybody here is familiar with the Elk Stack, Elastic Stack. You might be using a service like Splunk, really commonly understood. But let's dive into what is a metric. So metrics are pretty simple. It's a metric name, a thing, what is it? It's a value, how much is it? And it's a time, when did it happen? But as we start to grow our systems and have larger scale systems that are more distributed, we need to start adding some metadata. So metrics should also include a tag of a where is it? Whether that's geography, whether that's what availability zone, what cluster it's from, maybe what service it's from. That helps us inform what's going on. And so when it comes to metrics, they're often aggregated or combined. And that allows us to understand trends and patterns. Because if I were to tell you, hey, CPU is running at 95%, on its own, that data point means nothing. So metrics, you aggregate them, you combine them, it allows you to understand the history of what's going on. So that 95% may be completely normal, or it could be anomalous, but you need context. But the nice thing about that context is it allows you to send alerts. So metrics is what you should often send alerts on. And in short, metrics help us understand the known unknowns, the things that we know about, that we know to monitor, but we don't know what their current state is. Also a Pokemon reference there. Logs, on the other hand, are event-based, right? Something happens, it generates a log line, and hopefully that log line is easy to read. It's easy to understand what's going on there. And hopefully it's verbose, provides you a ton of information, and it's structured so you understand how to read that information and what the parts of that information is. And they're primarily useful for finding those details of those events, what happened. And so we say that logs are particularly useful for catching the unknown unknowns, the things that we didn't know to monitor, that we had no idea of what their state was. All right, so I talked about systems thinking. Let's take our system and rotate it, right? Let's take a look at the back-end visibility. What's the data here? Well, obviously we have metrics and logs, but traces are the new data. Traces have become far more important these days as applications get distributed. So the tool here that we ought to use is the APM, Application Performance Monitoring, which is a complete misnomer. All of these tools, everything that provides you visibility into your systems is performance monitoring. So what do traces provide? Well, traces are a request-based piece of data. It follows the activity from a request in your system to other functions, to other services, and they help you understand and answer the question of where in your code, where in your services something happened, and also importantly, how long did they take, right? Because latency, we understand, how long things take is an important thing. So let's take our application, rotate it one more time, front-end visibility. Here the data is largely going to be metrics again, but now we have two new tools, real user monitoring, sometimes called RUM, and synthetics. I like to say that RUM and synthetics are people and robots, and unlike the movies, the best way that we can live is with people and robots together. Hopefully robots don't rise up and kill all the humans. Hopefully humans aren't like so freaked out that we destroy all the robots. But RUM and synthetics work really, really well together, right? Because if you have monitoring on real user actions, that provides insight into what they're actually doing with your product, not what you think they might be doing, not conjecture, but actually what they're doing. And that can inform you how to essentially build your robots, the synthetics. And the synthetics allow you then to test your applications independent of users because hopefully you're able to find those issues before real users are actually experiencing them. So I gave you a ton of really dry information about a bunch of tools and about data and how we should look at systems. And at this point, you're like, what does that all mean? I don't care. So here's a great example. I've got an app called Datadog. It's Tinder for puppies. fantastic app, right? Who doesn't want an app where you just look at cute puppies all day and you swipe right and maybe, I don't know, you can go on play dates with puppies. It's a fantastic app because we all love puppies. And yeah, Corey just said he would invest in it. Yes, Corey Quinn also creates apps based around dogs, like Twitter for puppies. But it's great. Everybody loves it. They tell their friends tell their friends. It's fantastic until suddenly it goes down. It's Pokemon Go all over again. Like, everybody's got the app, and the app just doesn't work. So how do we understand what went wrong? How do we even know that something went wrong, right? That's the idea of monitoring, is that hopefully we know something. And we could take the Niantic approach of how they knew Pokemon went down. But this probably isn't a good way to monitor things, right? So let's take a look at some of these tools and understand how the perspectives come into play. So if we're thinking of the front end, and we get our front-end developers and our front-end engineers involved in the monitoring process, getting those alerts, well, they should be using real user monitoring. And we're all familiar with dashboards, and so should our front-end engineers. So what does it look like with real user monitoring? Well, the metrics that we really want to look at here are views, right? So we want to know how many users are actually trying to use our product. Views can sometimes be different from requests, depending on how you build your application. But then the second metric that we really need is interaction, and that's where real user monitoring becomes very, very important. We want to know not just how many people are trying to use our app, but if they're actually using it. So we measure key interactions. That could be clicks on specific things. That could be scrolling interactions if we have, long content on a website or something like that. So if I'm looking at a real user monitoring dashboard, I can see here that my views are going up as I move to the right. But my interactions, which is that lighter purple, they're going down. So we can understand inherently that if we have more users, we should have more interactions, or at least the same proportion and amount. So in this case, it's going down. Our front-end engineers can also use synthetics, right? They can set up some automated testing. And what does synthetics look like? Well, typically, again, looks like your basic dashboards. And the thing that we want to measure, we don't want to measure that interaction because we've scripted those robots to do things. So we already know that they're going to be acting. But we want to measure how long things take. Latency is the big thing that we want to measure with synthetics. And oftentimes with synthetic tools, it's really cool because you can get a film strip like this on the bottom, where we can see at various time intervals, what does our actual application look like? So we can start to understand how long it took for things to load, what the experience is like in terms of latency. So let's take an example scenario. At the Datadog app, we use Fastly to be our CDN because we have tons of puppy photos. Fastly is a great CDN. I've loved their product, but they also get hit with DDoSes a lot, and largely they're really good with mitigating those, but what if they're not, right? What if they suffer a massive DDoS attack? What does that look like for us? Well, if we're using RUM and synthetic tools, then we can get alerts on that, right? Because with RUM, we can see a decrease in interaction, because if people aren't getting puppy photos, nobody's going to swipe right to try to connect on a play date with a puppy. Or we can see that things are loading slowly with synthetics. But if we're relying on the traditional monitoring tools that we're using, like infrastructure monitoring, like Nagios, or if we're using an APM tool, no alerts there, right? So from an ops engineer perspective, hey, system's running fine. From a front-end engineer perspective, things are horrible. So trying to get those multiple perspectives to understand what's going on is important. So tracing, let's move on to tracing. Again, this is going to be a tool primarily used by your back-end, your software engineers. Traces run on requests. So there's the idea that when someone makes a request against your service, we want to capture that or get a sampling of that, because if we have a high-use application or website, you're going to get a lot of requests. And this does impact users when we run it. So we'll sample that down. And the primary metric here that we're looking for is latency. So we want to see a distribution of latency. And it should look something like this, where most of your requests, most of your interactions are going to be fairly short. And then as time goes on, we have that long trail off, because hopefully most of our interactions are going to be short. How do we know something went wrong? Well, you might get a latency distribution like this, where you've got a weird buildup at that 50th percentile, which means 50% of your users are having this kind of slow experience. And even worse here, if we look all the way out to the 90th percentile, all the way out on the right, there's a little bump there, which means that 10% of our users are having a really horrible experience. But the nice thing with trace is that it allows you to dive into the actual trace, what's going on. And those typically look like this. It's a flame chart. Each of those bars that's running across there is what's called a span. Spans represent a function call, and the length represents how long it took. And each subsequent bar underneath that, or each subsequent span, is the next function call, or the next service that was called. So if I zoom in here, we can see that I first had a request that came in, and that passed off to a function called dispatch, passed off to a base call, and so on. And we can see that cascade of how those functions were called. And if I have something that goes wrong, well, then probably, let's see if this plays. Is that going to play? So we can see for this particular one with an error that it took a long time, and those little purple bars on that first slide are now just tiny slivers. So it gives us an idea of where we can look within our code to understand what's going wrong with it. So let's take an example scenario, right? Service outages. How many people are building their applications on microservices or other third-party services? You reach out to, you make an API call to something, right? How do you understand that something goes wrong? Well, at the example Datadog app, we use an image resizing optimizing service. Resizes images asynchronously, passes them back. If that has issues and images are returned slowly, then users have a bad experience. So with RUM and synthetics, we might be able to see this, right? Your front-end engineers might be able to see some of the symptoms of slowness in your back end, but they won't exactly know where. And from an ops perspective, hey, everything's still fine. My servers are running quickly. It's delivering up the things that it needs. But really, that's where the APM can help us, because we can alert on latency on those third-party services when our code is taking a while to receive responses back. Let's start to transition to other back-end engineering. Application monitoring. How do we know? Well, this is a pretty common scenario. None of us really have to imagine this or stretch our imaginations to understand this, but a developer deploys bad code. For example, a developer deploys code that improperly checks for password hashes. So suddenly, it seems like all passwords are just bad passwords. RUM and synthetics, how do we know? Well, we don't. Our front-end engineers would never know that this went wrong. From their perspective, users are just like really bad at typing their own passwords. Infrastructure monitoring, same thing, right? Ops engineering perspective, things are running fine, servers are great. Application monitoring here is very important. We need to understand that for our software developers, custom metrics on the things that are important to the business are critical. For example, if logging in is important to your company, well, set a metric on logging in. We're all, again, familiar with the dashboards, right? We have some sort of dashboard or graph, and we can see that it just starts to drop off. So let's shift and rotate our application one more time. Ops engineering, what are we looking at? Infrastructure monitoring primarily. Infrastructure monitoring, what we really want to be monitoring on is resources. Do you have capacity? What's your utilization look like? So, final scenario. We're just too popular. Everybody loves puppies, and we're completely out of resources. From a RUM, synthetics, APM, application monitoring, performance standpoint, we'll probably receive alerts that latency is high, but they won't be able to help us identify any reason why. Infrastructure monitoring, on the other hand, the traditional thing that I think most people have is going to be good for this. Your Nagios, your Sensu, they'll all be able to alert you that resources are high and maybe even trigger some automatic resolutions or remediations, auto-scaling your systems up. As a side note, side tool that you might want to look into, anomaly detection. Sometimes the things that we're looking at have patterns and trends that are difficult to understand why, or not be able to alert on single static thresholds. So there's a lot of good anomaly detection out there, both services and open source. For example, LinkedIn has a great project called Luminol that will allow you to do this. So all of these monitoring tools from our different teams, from our different perspectives, can let us know that something went wrong in various ways. But how do we know what went wrong? Well, in order to find out what went wrong, we need to recurse down. We take a work metric, which is going to be a high-level business metric, something that we need to accomplish, and we always want to take a look at the resources that help us provide that, and then correlate any sort of events. And you can start to work your way down. So we start with the high-level business metric of, is our application running? Are people able to interact with our application? And we see the services behind that. So with the Datadog app, if our photos aren't showing, that's one of our services. So then we can drill down, look at that service. What composes that services? Well, you look at the components. For example, that third-party API that's resizing our images. And then you try to correlate those events, what happened around that could help us understand it. And that's where logs come into play. Logs are highly important because logs are those record of events, so we know what's going on. So how do we get 100% visibility? What do we need to understand is that we first need to think about our systems as a whole. We need to understand that we're not different silos, we're not different tiers, we're all working together on the same thing. And then leverage those multiple perspectives. Understand that our front-end engineers are going to get different information from their tools than we are as an ops engineer, or that somebody else is as a software developer. And gathering all of those together is important. That's really the crux of DevOps. That's what we're trying to understand by working together. And then consider all the tools that you need. If you're just running infrastructure monitoring or application monitoring, if you're just forcing your ops engineers to be those people on call and to monitor things, then you're going to be missing out on those other perspectives. So consider getting those other tools to help your other engineers, your front-enders, your back-end software developers, get them on board, provide them the tools that they need so that you can work together to get that complete visibility. Thanks.